Hi again. Now let us do another potential multiplicative inverse that you might need to calculate when you are solving a problem in Chinese remainder theorem. Normally in exam, the number that you encounter is large number. So there is no way for you to use inspection approach in solving your multiplicative inverse. Your professor would insist you to use Euclid's algorithm. So no excuse for not using Euclid's algorithm. One example over here is that you may encounter this congruence 1820x congruence to 1, of course, because we are looking for the inverse in mode 99. Judging from the value of mode and the value of number that you're looking for the inverse, which is too large compared to the mode, so it's better for us to get the remainder of this divided by 99, which is, let us use calculator, 1820 divided by 99 minus 18, multiply back with 99, we get 38. So it is 38x congruence to 1 mode 99. Then we have the value of mode and the value of number that we're working on. Now we have the value of mode larger than the value that we are looking for the inverse. We can use Euclid's algorithm. Next, we take the mode, which is 99. We want to decompose it into multiplication and remainder. Multiplication of what? Of 38, which is this number. Now, the number becomes mode. The mode becomes the number. Why? Because the mode is now larger. Adding with a remainder. So, 99 divided by 38. 2. Then the remainder is subtract 2 multiply by 38, we get 23. So this is 2, remainder is 23. Next line is we take 38. Now the mode is 23. Since 23 multiplied by 2 is already close to 50, so this one should be 1, and then the remainder is 38 subtract 23, we get 15. Then we shift 23 over here. 23 become the number they want to compose, and the mode now is 15, and 15 is more than half of 23. It should be 1. Then the remainder is 23 subtract 15, 8. Next is 15 decomposed into 8. This is a 1 plus 7. Next is 8 in terms of 7, 1 plus 1. So by getting a 1 over here, we know that our Euclid's expansion is correct. Next is to do the reverse replacement. We move 1 multiplied by 7 to the left, and everything on the left we swap back to the right. So we have on the left is 1 equal to 8 subtract with 1, 7. Then again, this is congruence because we have a mode and a number and a remainder. This is basically a congruence, meaning the 7 in this line, 7 in mode 8 is identical or congruence to 15, meaning we can replace this equation with 8 minus multiplied by something but we don't know yet, but 7 is replaced with 15. Oh, sorry, this one is still 1, but what we need to change is something related to 8. 1 multiplied by 15. What is, when we subtract 15, we get a 1, of course, 16. And 16 divided by 8 is 2. So if your work over here in decomposing process is correct, you should be able to get the reverse replacement with very nice number that don't have any remainder. Alright, next, after 7 is 8, which is this one. You need to replace 8 with something. With what? You replace 8 with 23 because in this case 8 and 23 are congruent in mode 15. So it is 2, 15, which is 30. You want to subtract something with, 2, 23. You replace 8 with 23. Then how many? 15. This is 46. We need over here, the value over here is 45, so that we get the difference of 1. So if we want this to be 45, what is the value of multiplier? It is 3, of course. Next, we want to replace 15. We already replaced 8 with 23. Now 15 with 38. So what is the value of multiplier here? We don't know. 23 subtract with 3, 38. What is 3 multiplied by 38? 3 multiplied by 38 is 114. We want the value of this part is as 115. So 115 divided by 23 is 5. So the value here is 5. The equation still balanced, still valid. Make sure the equation still valid. 1 equal to 5 multiplied by 23. Subtract with 3 multiplied by 38. Then, just now we replace 15. Next, we want to replace 23, which is this one. 1 equal to 5 multiplied by 23. 99. Subtract what? 5 multiplied by 99 is 495. What we want is 494 over here divided by 38. 494 divided by 98. We get, 494 divided by 38. We get a 13. 13 multiplied by 38. And we get this equation in terms of the original simplified congruence, 38 and 99. See, 99 and 38. So we go back to mode 99. We get 1 congruence to this part is 0. Mode 99 applied to 5 multiplied by 99. The mode is definitely 0. So it is a negative 13 multiplied by 38. Go back to the original simplified equation. In this case, x is negative 13. X is congruent to negative 13. And we want it to be a congruence positive number less than 99. So 13 negative, we add with 99. We get 86. Mode 99. Alright, we can verify this by replacing back to the original equation. 86, the inverse, multiplied by 38. Then to get the mode, divide by 99. Then subtract 33. Multiply back with 99. We get a 1. So the inverse is correct. We can even replace to the original unmodified congruence. 1820 multiplied by 86 divide by 99, subtract 1581. Of course, multiply back with 99, you will get a 1. So 86 is correct. Now, if you want to do this by inspection, you have to multiply 86 times. That will be a waste of time. I insist you use Euclid's algorithm. Just a few lines. make sure you press your calculator correctly.